Hello, my name is Ilana Deyneko, and I'm in Chem 102, the Friday session. Today I'll be doing a question from topic 15. The question is, let's practice number 2, question number 2. The question is as follows. Combustion of a 0.9835 gram sample of a compound containing only carbon, hydrogen, and oxygen produced 1.9 grams of carbon dioxide and 1.072 grams of water. What is the empirical formula of the compound? Since it is a combustion equation, we can know the following. The compound has to react with the oxygen in order to produce carbon dioxide and water. The first step is to figure out how many grams of carbon there are in the carbon dioxide. We know the amount of carbon dioxide, so we must multiply by the ratio of molecular weight of carbon over the molecular weight of the total compound. To find the grams of hydrogen within the given amount of water, you must find the ratio of molecular weight of the two hydrogens over the molecular weight of the total compound and multiply that by the given amount of water. The next step is to find out how much oxygen there is in the compound. To do this, you subtract the sum of the grams of hydrogen and the grams of carbon from the total amount of compound. The following step is to find out how many moles of carbon there are in the compound. We have already found how many grams of carbon there is, so you must divide it by the molecular weight of carbon. The molecular weight of carbon is rounded to 12. This gives us the amount of carbon in the compound. For hydrogen, you must do approximately the same thing. You must divide the amount of hydrogen that you found previously by the molecular weight of hydrogen, which I have rounded to 1. To find the molecular weight of oxygen, you must do as you have done for hydrogen and carbon. You must divide the grams of oxygen we have found previously by the molecular weight of oxygen, which I have rounded to 16. This is the answer you will get, but I have rounded it to 0.0216 moles of oxygen. After finding all the moles, which are shown here, here, and here, we need to find the ratio. To do this, we divide the moles by the smallest mole, which in this case is the oxygen. So the oxygen equals to 1, the hydrogen equals to about 5.5, and the carbon equals to 2. Since 5.5 isn't an integer, we have to find the next multiples for all of them that will work. So I did this by multiplying them by 2. What I got is 4 for carbon, 11 for hydrogen, and 2 for oxygen. This is the final empirical formula. I have reorganized all the information into a table, just as in the videos. This shows us the full process, going from grams to moles to the empirical formula ratio, and finally finding that carbon has 4, hydrogen has 11, and oxygen has 2. The final compound should look as follows. This is the answer to the question. Multiple choice D. Thank you.